You have been told that the Neanderthals went extinct. That is mostly true. It is not completely true. Because if your ancestors came from anywhere outside Africa, you are carrying a piece of them right now. Not as a metaphor, as actual stretches of DNA, sitting in your cells, doing work today. Roughly 1 to 2% of your genome was written by a different kind of human. A human who disappeared about 40,000 years ago. This is the story of how we found that out, and what they left behind in you. Start in a limestone valley in Germany, in the summer of 1856. Quarry workers blasting a cave find a skullcap and some heavy limb bones, and nearly throw them away. The skull is wrong. Long, low, with a thick ridge of bone across the brow. Nobody has a category for it, because the theory that would explain it has not been published yet. Charles Darwin's book is still 3 years away. So the experts guess. One says it is a deformed man. Another decides it is a Russian soldier who crawled into the cave and died there. The valley was called Neanderthal, and the name stuck to the bones. 50 years later, a French scientist named Marcelin Boule reconstructs a fuller skeleton. He gives the world the image almost everyone still carries: stooped, bent knees, head jutting forward, dragging a club. The brutish caveman. There is one problem with it. The skeleton he used belonged to an old man riddled with arthritis. Boule had reconstructed a disease and called it a species. The correction took most of a century. Here is what they were actually like. Shorter than us and far stronger, with a broad-barreled chest built to hold heat in an ice age. Big noses to warm freezing air before it hit the lungs. And a brain case that was not smaller than ours. On average, it was slightly larger. Some of them had pale skin and red hair, from a gene variant not found in humans today. They controlled fire, made stone tools to a consistent design, and stitched hides for clothing. They cooked birch bark into tar to glue stone points onto wooden shafts. That process needs a sealed, oxygen-poor fire held at the right temperature for hours. It is chemistry, done 50,000 years before anyone wrote anything down. They used pigments, collected eagle talons, and pierced shells. In Spain, cave paintings were dated to 65,000 years ago, before modern humans reached the region at all. And in a cave called Shanidar, in northern Iraq, they buried their dead. One of those skeletons is the reason a lot of people changed their mind about Neanderthals. A man in his 40s. His right arm was withered and had been amputated above the elbow. He was blind in one eye from a crushing blow to the face. He was probably deaf. He had a badly healed leg. He could not have hunted, and he could not have run. He lived like that for years, which means somebody fed him and kept feeding him. That is not a detail about biology. That is a detail about what they valued. Their skeletons carry another clue in the pattern of the injuries. Broken bones cluster in the head, neck, and upper body, and almost never in the legs. A famous comparison found the closest match in modern medical records was rodeo riders. Because they hunted bison and wild horse at arm's length with heavy thrusting spears. There was no bow, no distance, no safe option. You walked up to something enormous and pushed. So they were not brutes. But were they family? For 150 years, that question had no way to be answered. Bones can tell you shape. They cannot tell you who somebody's ancestors were. Then a Swedish scientist called Svante Pääbo spent 30 years on a problem everybody thought was unsolvable. Reading DNA out of something that died tens of thousands of years ago. Ancient DNA is a wreck. It shatters into short fragments and chemically rots. Worse, it is buried under contamination. Pääbo's early attempts kept producing beautiful human DNA sequences. They were his own. He was sequencing himself. So the work moved into sealed, clean rooms, with filtered air and full-body suits. Every fragment had to be sorted, matched, and reassembled from millions of overlapping pieces. In 2010, his team published a draft genome from bone found in Vendija Cave in Croatia. For the first time, we could read a Neanderthal directly. And then they ran the test that changed everything. The logic is simple. If Neanderthals were just a separate branch that died out, then every living human should be exactly the same distance from them. Africans, Europeans, Asians, all equally far away. That is not what came back. People with ancestry outside Africa were consistently, measurably closer. There is only one thing that produces that pattern. Somewhere on the way out of Africa, the two groups met, and they had children together. And those children had children, all the way down to you. The best estimates put the main encounters in the Middle East, between 50 and 60,000 years ago. And it was not one meeting. There were several separate episodes, in different places, over thousands of years. Then it got stranger. In the same year, a single fragment of a girl's finger bone from Denisova Cave in Siberia was sequenced. It was not modern human, and it was not Neanderthal. It was a third kind of human nobody knew existed. We found them by their DNA before we had enough bones to describe their faces. They are called Denisovans, and people in Papua New Guinea and Melanesia carry up to 4 or 5% of them. And in 2018, a bone splinter from that same cave produced the single strangest result in the field. A teenage girl whose mother was a Neanderthal and whose father was a Denisovan. Not distant ancestors, her actual parents. A first-generation child of two different human species. The researchers named her Denny. If you have ever spat in a tube and mailed it off to one of those ancestry companies, you have seen this already. There is a line on the report giving your Neanderthal percentage, and most people read it as a fun fact and scroll past. It is not a novelty statistic. It is a receipt for something that happened around 50,000 years ago. So what did you actually inherit? Start with the obvious. Genes affecting skin and hair. Keratin variants that came from populations already adapted to European and Asian light for hundreds of thousands of years. Then the immune system, which is the useful part. Humans walking out of Africa hit a wall of unfamiliar diseases. Neanderthals had been living with those diseases the whole time, and had immune variants tuned to them. Interbreeding handed our ancestors a working immune upgrade in a single generation. The most dramatic version came from the Denisovan side. Tibetans carry a gene variant that lets them live above 13,000 feet without their blood thickening dangerously. That variant was traced back to Denisovans. An entire population lives at altitude today because of a gene from a species that no longer exists. It is not all useful, though. Some archaic variants are linked to higher risks of blood clots and to differences in pain sensitivity. And in 2020, Pablo's group found a stretch of Neanderthal DNA on chromosome 3. That raised the risk of severe illness from COVID, carried by hundreds of millions of people. The following year, they found a different Neanderthal segment that protects against it. This is the part worth sitting with. That code is not a fossil. It is still running. Not everything survived, though. Large stretches of our genome are swept completely clean of Neanderthal DNA. The emptiest regions sit on the X chromosome and around genes involved in fertility. The likely reason is uncomfortable. Many hybrid males probably could not have children. Evolution quietly deleted those sections and kept the rest. And here is the number that surprises people most. Any one person carries only about 2%, but different people carry different 2%. Add it all up across everyone alive today, and at least a fifth of the entire Neanderthal genome is still out there. Not preserved in a museum, distributed across billions of people. So why did they go and we stayed? There is no single dramatic answer, which is usually the sign of a true one. Their populations were small and scattered, with very little genetic diversity. The climate swung violently. Modern humans arrived in larger, better connected groups. Small isolated populations do not need a catastrophe. They need a run of bad decades. The last solid traces of them come from about 40,000 years ago in Western Europe. After that, the tools stop appearing, and so do the bones. And some of them were not replaced at all. They were absorbed. Which brings it back to that skullcap in a German quarry in 1856. The workers who found it had no idea what they were holding, and neither did the experts. It took us 154 years to work out the answer was relatives. They did not vanish. They moved in, and they are still here.